Hey, this is Keith with Vantech Consulting. First off, I'd like to welcome you to the channel, and if you're a subscriber, appreciate your subscribing to the channel. If this is your first time, welcome. Hope you find the information informative and useful. One of our viewers threw down the gauntlet. They didn't actually throw down the gauntlet. They more or less asked a question. They asked if we could put a VFL, a 100 milliwatt VFL, on a 25 kilometer spool of fiber to see what would happen. That's what this video is about. Stick around and we're going to find out. Okay, so 100 milliwatt, 100 kilometer VFL. Here's the deal. It will never go 25 kilometers. It won't go 100 kilometers. It's not going to happen. It's never going to happen. 650 or 635 nanometer light, it gets absorbed into the fiber. So what do we know about light and energy? It cannot be destroyed. It can only change form. So what does absorption mean in fiber optics? It means that the light is converted to heat. So this happens very quickly at 635. All that light that's traveling in there is going to be converted to heat in the fiber, and hence will not ever go greater than somewhere around, 7 kilometers or so. So with that said, this is our test bed. We've got 1 kilometer launch bags, and we've got a 500 meter launch bag, half a kilometer. It is going 7.232 kilometers, all right? Overall loss on this is 6 dB. The other thing that we're going to do is real quickly, just to make sure there's no shenanigans going on, we're going to test our batteries here. So we can see that that's absolutely brand new, fresh battery, because we have experienced in testing the other VFLs, as soon as these batteries drop down, again, top performance there. As soon as the batteries start to wear down, the power drops on the VFL. And I have no way of measuring the accuracy of the 100 milliwatts coming out of this. All right, just to be fair, I don't have the most I can measure is about 40 milliwatts at this wavelength. All right, so let's take this guy out of the package here. Take this guy out of the package. There we go. All right. What do we got? We got a little adapter here that goes to an LC. We got another little ceramic spacer for the connector. We have our flashy gold VFL. A little bit of a wristband. Some helpful instructions in Chinese. A little case for it. So not bad, but let's go ahead and get this thing put together. Okay, we'll throw a couple of batteries in here. And again, apologies that I don't have a power meter that will measure down to this guy. So again, we're going to go ahead and get this out of the way. We're going to take our connector out. We'll put him over here. Plug him in and fire this baby up. All right, so we got light. We can see a lot of light escaping at this point. Let's go down to this end. And if I look directly at it, I can see just a very, very small pinhole of light. In other words, it's really not usable. Get in as close as we can get. I don't know if we can see this. Maybe if we... I don't know if you can see that. I'll get that on the microscope and pop that in. But again, this just a short video. Don't waste your money on this. Let me give you an example here. So this is 100 milliwatts, right? So that basically is like 20 dBm. So 20 decibels reference to 1 milliwatt. We're going to put a 20 milliwatt on there and see what the difference is. All right? This guy's got to go back to Amazon. This, by the way, is $80. So, all right, we're going to go ahead and throw our 20 milliwatt on here. Pop this on. Okay, solid light. And again, if I look down here and I'll do the microscope on this, but it's about the same. I mean, it's neither one of these is usable. So I mean, you're not going to go into we're not going to be able to go into a splice case and identify this by doing a macro bend or anything. I mean, you can't even see the light on a white box. So again, I know there's people out there that tell me that they've gone out, 5, 6, 8, 10 miles. And the only thing I can say is you have, I'm not going to argue with you. I mean, if you got a VFL that's going to go 10 miles, I'd sure like to know exactly which one it is so I could test that. But again, it's the physics of it. It's impossible for it to get out that far. So I hope this clarifies for you. Again, absorption is the primary factor here for the loss of the light going out, and all of them, it doesn't matter what the power is, will not go out anywhere past about 7 kilometers. 5 kilometers usable is about what it is. And somewhere in the world, somebody has equated 1 milliwatt of power with 1 kilometer of reach, and again, that's not accurate. So I call shenanigans on the advertisement. If you're buying one of these, a 20 milliwatt, these guys here work great. 30 milliwatt would be about the maximum I would get. It's going to make the light, in the usable light or usable distance, it will make the light brighter. But again, that increase in brightness also exaggerates any defects and faults you have. So you start getting feathering on splices and stuff when you're looking in a case, and you're going to don't start cracking splices and redoing it based on a VFL, right? The only way that you should be doing any kind of splice analysis is on this guy, on the OTDR. Okay, so as I said, I hope this has been useful. I hope it's informative and save your money. Buy the less expensive guy. All right, until next time, be safe, and we'll see you on the next video. Thanks for watching.